Hey guys, welcome back to another lesson. Previously we were talking about angles and arcs and their measures and their relationships in circles. And today we are starting kind of a new grouping of sections, and we are going to be talking about line segments in circles and their ratios. So we're going to start with the chord ratio. Remember, a chord is a line segment that has its endpoints on the circle. So if we picture two chords intersecting, like the green and the purple lines shown here, then if we draw in the dashed lines, like if we connect their ends, we get two triangles, right? You get this triangle on the left, and then we get another triangle over here on the right, right? Well, what is the relationship between these two triangles? They are similar. We know they are similar because we can see that we've got angle W and angle X that both intercept this arc ZY, which means that those angles are congruent, okay? So that's one pair of angles. To prove that something's similar, we need two angle pairs. Well, we also know that angle WPZ and angle XPY are vertical angles, so they are congruent. And if you have two pairs of corresponding angles that are congruent, you can make the claim that the triangles are similar. So triangle WPZ is similar to triangle XPY. Okay, why does that help us? Because we know that if triangles are similar, their sides are proportional. So what I'm going to do is I'm going to set up the proportion of these sides. So in this diagram that we've got here, side length A corresponds with side length D. So A over D. And that would have to be equal to side length B corresponds with side length C. And actually this is, here, let me see here. I would need to do, A is from the small triangle, so I would put C on top. Dang, it's been a while since I've done this too. Okay, so it'd be C over B. Sweet. So now if I cross multiply, I get A times B is equal to C times D. So pretty straightforward, right? You could set up this proportion every single time, or I think the easiest way to remember this ratio or remember this relationship is just you're multiplying down the chords. Part times part equals part times part. Let's look at some examples here. Okay, so as I'm looking at example 1, I have, let's see here. I've got two different chords here that are labeled with side lengths. So I am going to multiply down one side length. So I've got 4 times X. And then I will multiply down my other chord that equals 11 times 8. Okay, so now if I just am continuing to show my work, 4x is equal to 88, x is equal to 22. I'm only looking for x, so I am done. Next, let's try another one. Once again, I'm just multiplying down my lines, okay? So 10 times 6 is equal to 8 times x. 60 equals 8x. What is 60 divided by 12? Or divided by 8? 7.5. X is equal to 7.5. Can it be a decimal? Sure can. Yes. Side lengths can be like 7.5, right? I can have the side length of a table is 7.5 feet. Is a length of a line segment. A decimal is okay. All right, let's keep going. All right, one more. Why don't you guys pause right now and try this one on your own? Okay, multiplying down the sides, you should get 12x equals 15 times 20. Solve that. X is equal to 25. All right, so this next one is a little bit tricky. Why is it a little bit tricky? because now I'm no longer determining the length of x. I'm looking for wy. Okay, so what I am going to start by doing is I am going to write in the one side length that I'm missing. I'm just going to call that x. Okay, now I follow the same process as before. 10 times x is equal to 15 times 14. Okay, so 10x is equal to 210. X is equal to 21. So x is equal to 21. Great, but that is not actually what I'm looking for. I'm looking for this full length of wy. What do I have to do? Well, I don't know. It's a real, it grinds my gears. I don't know. So all I have to do is add them together, right? I've got 10, oopsies. 10 is a portion, 21 is a portion. So wy is equal to 10 plus 21, which is just 31 units. So my final answer is 31. All right. Next, same skill right here. Why don't you guys try this one on your own? All right. Pause the video, see if you can do it. Okay, I went through, did my multiplication. I found that x, that little part, is equal to 6.25. Adding that to 12, I get 18.25 is that full length of ZV. All right, cool. Next, this next one, problem number 6, this one's different, okay? So we haven't seen this before, but we can do it, all right? MP is equal to 4. I'm going to go ahead and label that. So there's 4. NP is equal to 9. Fabulous. ZP is equal to PY. So what I'm going to do is I'm going to call ZP X. And since ZP is equal to PY, I'm going to call X also because they're congruent. They're the same. And I need to determine the length of ZY. I'm just going to go ahead and highlight that so I don't forget. Looking for that full length, okay? So step 1, solve for X. Let's do this. So 9 times 4 multiplying down the sides is equal to x times x. Okay, setup, so far so good. Part times part equals part times part. 9 times 4 is equal to 36. X times x is equal to x squared. What do I need to do now in order to get x by itself? Well, I'm going to take the square root of both sides. Square root of 36 is 6. So 6 is equal to x. So if I've got one side length here, that's 6, and another side length that's congruent and is also 6, 6 plus 6 is equal to 12, which is the length of zy, which is what I was looking for. That's it. All right. Okay, if you have any questions, comments, concerns, whatever, feel free to email me as always. Otherwise, we'll see you in the next lesson. Have a good night.